Alright, hello again. We're going to do chapter 13.3 and 13.4 all in one go, in which we're going to be factoring polynomials, more specifically trinomials of the type ax squared plus bx plus c, where a, b, and c are constants and x is our variable. The first thing you're going to learn in 13.3 is the FOIL method, in which we have a leading coefficient no longer is 1 but something else. Now how we tackle the FOIL method is it's kind of like we're reverse engineering how we FOILed out a polynomial. If you remember, we had something like, I don't know, I'm going to give you a crude example, like x plus 4 and 3x plus 7. This is not the solution to this guy. So what we would do is we take the first times each other, and we find that we'd take the outers, the inners, and finally the last, and we'd multiply it all out, and we would find the resulting trinomial. For this method, we're kind of going backwards, where we look at, okay, what are the possibilities of the first being multiplied together and the last, and then we'll work on the middle. So let's go ahead with that kind of idea in our head. I know it's not quite there. We're going to get there. We're going to look at the first guy. We're going to find all factors. Well, you don't have to always find all, but we are going to find all factors of 14. And we call him our a, which is our leading coefficient, and it's lowercase a. So we're going to write 14 and list off factors of 14. So there's 1 and 14 and 2 and 7. And that's it. So I listed them off, all of them, just to be safe. Sometimes you can eliminate some of the factors because they're very large or they're very small and they're not going to work for that middle term, which we're going to get to. So using these factors, I'm not going to worry about the signs for the a. I have the possibility of this factoring where it will look like I have 1x times 14x plus the whatever part, right? Because x times 14x gets me 14x squared. Or I could have a possibility in which I have 2x plus whatever times 7x plus whatever. Because 2x times 7x is 14x squared. So you can see where the first term is developing. And you could do that mentally if you want to. I just list them all out. So now, our next step is to try to figure out our last guy. So we'll work with him. Maybe I'll call him green. So now we're going to find factors of c. Now, the nice part about c is that it's still dependent, its sign is still dependent on the b term. So we still look to b to help us out with our signs. So I'm going to extend this page a little bit. Alright, so c is 3 here. We need factors of 3, which is nice, 1 and 3. b still helps us out, so what's the sign of b? It's positive, so the bigger factor is still positive. And because c is positive, the other factor must be positive as well. Now, what we're going to do is list off all possible factorizations of our polynomial. So here's a possible factors forms. Alright, so this is going to be the funky part for most of you. See our step 1, in which I had the possibility x and 14x were together, or I had 2x and 7x. So I have the possibility that I have x plus 1 factor, let's say plus the 1 that I found from c, and 14x plus 3. I also could have the option in which those are switched, in which I could have x plus 3 times 14x plus 1. Now that's just one of these guys, right? I took care of him. Now I need to do the 2x and the 7x one. And I just don't mix and match because remember we need the first to multiply together and the last to multiply together. So I can have 2x, that's a bad place to put it. Let me just extend my page. So I could have 2x plus 1 times 7x plus 3. Or I could have those factors of c swapped, in which I have 2x plus 3 times by 7x plus 1. These are all the possible factored forms. And now it's up to me to figure out which one of these is the actual true factor form. Now, by working out the outside-inside, because I know the first are going to work, and I know the last are going to work. I did that in step 1 and step 2 by finding factors of a and c. So what I'm concerned with is outside-inside check. So we're going to do the outside-inside part of FOIL. So what I'm going to do is outside first. X times 3 is 3x. Plus the inside, 1 times 14x is 14x. 3x plus 14x is 17x. And now it's up to us to go back and say, okay, was that our middle term? And let's see. And it was 23x, right? So this is no good. I toss it out. Not an option. And now we'll do this again. So we have x times 1 is 1x. Plus 3 times 14. Well, 3 times 14, let's see, is 42x. And 1 plus 42 is 43, so he's no good. And you might have been able to eliminate these guys because they're very far apart. Usually when the numbers are relatively small, you want them to be close to one another. So let's see. Let's try 2x times 3 is 6x. 1 times 7x is 7x. 6 plus 7 is 13. Alright, that's no good to us. And last but not least, we have 2x times 1 is 2x. 3 times 7 is 21x. And 2x plus 21x is in fact 23x, so there's our middle term. So this is our factored form. And we're done. This boxed answer is our factored form of the polynomial. Now, that's the FOIL method. So that's what you learn in 13.3. We're going to also now do 13.4, in which it's factoring the same type, ax squared plus bx plus c, except we're going to use a thing called the AC method. And it gets its name from A and C. We're going to do a little bit funky stuff with it. And I'm going to teach you the quick AC method. There's another AC method out there that is by grouping. I will link a video to that as well. But we're going to do the quick and dirty method. So here we go. Our first step is to find factors of AC. And AC is just as you imagine the A and the C, and I multiply them together. So we're going to take 14 and times it by 3. I know that seems kind of brutal, but that's what we're going to do. 14 times 3 is 42. And now we need factors of 42 whose sum is 23. So you got 1 and 42, 2 and 21, and you could keep on going, but you might be noticing, there it is already, right? 3 and 14, what is it? 6 and 7, and that's it. So those are all the factors of 42. B still determines the sign for us. So that's the one consistent thing in factoring when you have trinomials. That B term always helps us out with the sign. It's positive, so the bigger factors must be positive. And 42 here was positive, so that means the other factor has to be positive as well. And you might be already noticing that we have that 2 and the 21, just like we did before, which adds up to 23. Now here's where it's going to be a little bit more interesting, funky, a little bit odd, but definitely more fun. So we're going to go ahead and take whatever our A was, our leading coefficient, okay? And I'm going to write him twice. I know that's weird because we know that's not right, 14x times 14x is definitely not 14x squared. It's 196x squared, which is way too big. But that's okay. We're going to fix that problem. The reason why I'm doing that is because I'm going to fill in my factors that I just found of AC in for the second part. And as you notice, it doesn't matter where I put them because 14x is starting both of them off. Alright, so now that you do that, and you know 2 times 21 is 42, which is not one of our last terms, which is 3, right? It's crazy how big it is. But we're going to fix that by getting rid of the GCF. So we're going to divide out the GCF of each binomial that we have here. So between 14x and 2, 2 is the GCF. Between 14x and 21, 7 is the GCF. Now look at this. This is the cool part. It's really nice. 2 times 7 is 14, and there's that extra 14 we had in there. It was too big by 14, and now we're getting rid of it. So we're undoing what we've done so that we keep everything the same. It's almost like we multiply by 1. It's pretty crazy. So we're dividing out the GCF. You have to remember that. That's why the AC method is sometimes not preferred by people, because you have to remember this funky little rule. And we will end up with 7x plus 1. And if you have trouble with this, go back and visit 12.7. And we have 2x plus 3. And this is our answer. And let's see if this is consistent with our previous one that we found through the FOIL. So we have 7x plus 1 times 2x plus 3. And I'm scooting back to the previous one. I just wrote in a different order, but same deal. 2x plus 3 times 7x plus 1. And we got the same answer. I don't really know what you might think is the easier method, but I can definitely assure you that AC is a little bit faster. Now, it's a little bit harder to understand because you have to remember the dividing out the GCF, but it is kind of quicker. So you decide which one you want to use, and that's 13.1 and 13.4.